Okay, so I'm going to be walking through how to do a problem from Unit 5, and I'll read the problem first. Are vegetarians getting enough protein? For people who practice some form of vegetarianism, the mean amount of recommended protein per day is 44 grams with standard deviation of 5 grams. In a recent random sample of 42 vegetarians, it was found that the sample mean amount of protein for this group was 40.6 grams with standard deviation of 3.1 grams. And A reads, address assumptions and conditions for this problem, and B says, how likely is it that this sample would give results as low as 40.6 or lower? Okay, so first for part A, I would list out the three things, which are, is it random? Random. Is it independent? Is it dependence? Independence. And is it normal? So for random, we can just reference back to the problem and look if there's any mention of an SRS or if it was random. So let's read it back. Are vegetarians getting enough protein? For people practicing for vegetarianism, the mean amount of recommended protein per day is 44 grams, with standard deviation of 5 grams. In a recent random, so there's our keyword right there. So since it says random, it is random, right? Given it is random. Now, to check for independence, we want to reference the equation n times 10 is less than large n, with n being sample size and large n being the population size. If you reference back to the equation, you can see sample of 42 vegetarians. So that is our n. It's 42 times 10 is less than all vegetarians. And I'm sure there's more than 420 vegetarians, so this checks out. It is independent. Now, to check if this is normal, we can use the central limit theorem, CLT, which calls for n, the sample size is greater than or equal to 30. And again, back to the problem, sample 42 vegetarians, we would get 42 is greater than or equal to 30. And this is true, so this checks out. This is normal. So B reads, how likely is it that the sample would give results as low as 40.6 or lower? So first, I want to just draw out a little distribution curve as well as I can and mark the mean, which is given in the problem here, 44 grams, and a standard deviation of 5. Want to remember these two. So first, just put 44 here, and we want to find our new standard deviation. To find that, the equation is our new standard deviation is our given standard deviation divided by the square root of n. And if we plug it in, we'll have 5 over the square root of 42, which is roughly 0.7715. It's a little better. It's very sloppy. So yeah, that is our standard deviation here. Link that back here, just so we remember. And it's asking how likely is it that the sample would give results as low as 40.6. And because it says low, that means we'll be shading to the left. 40.6, we'll just eyeball it, maybe like right here, 40.6, and we shade to the left, right there. Now, to get our z-score, to find out what this actually is, we want to go back to this equation. Z is equal to x minus mean over standard deviation. And we plug in our values here, so we'll get 40.6 minus 44 divided by 5 over roots 42. And this should outcome negative 4.4069. Now, once you get your z value, you want to go to your calculator and go to normal CDF. So from the start, you go second vars, and then 2, or normal CDF. And for lower, this is our lower part right here. So that would be negative infinity, or negative 1 E99. and our upper is our z value, which corresponds to this. So negative 4.4069. So we put that as our upper, and we'll leave our mean and standard deviation as 0 and 1. The paste will get a very small number, but this shaded region will be 5.247 times 10 to the negative 6. And that is your final answer.